Now, section 5.2, we're still dealing with exponents, but we're going to talk about the exponent of 0. Before I do that, let's say I had 3 to the second times 3 to the 0. I know in the last section we talked about when the same base, we just add the exponents, so 2 plus 0, I get 2. That means that 3 to the 0 did nothing, but I got the same answer. But we learned that in multiplication, the number that does nothing is 1. So anything, anything multiplied to the 0 power is going to equal to 1. So I have, for example, here, 60 to the 0, I'm going to say it's 1. Anything to the 0 powered, it's 1. Negative 60, all to the 0 powered, I'm going to say it's 1. Even though my base is a negative number, anything to the 0 powered is 1. Now, looking at C, my answer in this case will be negative 1. And the reason why, because the 0 powered, only goes to the 60. Notice how in my example B, I had the negative inside the parentheses. So the exponent of 0 did cover the negative sign. But in this case, the 0 powered only goes to 60. So I know 60 to the 0 is 1. But because of the negative outside, my answer is negative 1. For D, I'm just going to call this 1. Because anything, I don't need to know the value of y. Anything to the 0 powered is 1. Now, another thing that we're going to see as an example is negative exponents. What a negative exponent is my number, I'm going to make it into a fraction, but my negative sign means to move it to the other side. And what I call sides is the top side and the bottom side. So the 3 to the negative 2, I'm going to bring it to the bottom as 3 to the 2. Notice I converted into positive, but I'm going to write it at the bottom. I cannot leave the top empty, so I'm just going to put it at 1. Same thing with my example B. Right, I'm going to make a fraction, but my 5 to the third will go to the bottom. The top, I cannot leave it empty, so it's just a 1. So negative exponents, move it to the other side. So if it was negative at the bottom, I would have moved it to the top. Let's take a look at C. To begin with, my exponents are 1. Notice I have parentheses. On section 5.1, we said that multiply the exponent on the outside, in this case negative 3, to the exponents on the inside. So we have 1 to the negative 3 over 2 to the negative 3. I notice they're negative exponents, so my 1 to the third, I'm going to bring it to the bottom. 1 to the third. My 2 to the third, I'm going to bring it to the top. Once again, if they're negative exponents on one side, and once again, side, I call it top side, bottom side. So if they're negative exponents on one side, convert them to positive exponents on the other side. Looking at my example D, I start with 2 to the negative 4 and 5 to the negative 4. So 2 to the fourth at the bottom, because remember, negative exponent means I'm going to switch it to the other side. And my negative exponent with the 5 means I'm going to bring it to the top. So my answer should be 5 to the fourth, 2 to the fourth. Negative exponents just converting into positive on the other side. So now let's take a look at another example. Let me do this one, example 8. Let me do it the long way. I have 5 8 times. 1, 2, 3, 4, 5, 6, 7, and 8. At the bottom, I have 6 times. 1, 2, 3, 4, 5, and 6. I could cancel this 5s. I could cancel this 5s. I'm just trying to cancel whatever repeats on both sides. So I'm just going to cancel those. I'm going to cancel those. And I'm going to cancel those. So it seems like on the top, I have 5 to the second. This is the long way. This is the long way. Now, the easy way, one way we could have gotten there, we could have just subtracted my exponents. 8 minus 6 gives me 2. The only thing, though, if we're dealing with positive exponents, So if we're dealing with positive exponents, make sure you put the answer on the side where the biggest exponent is, whether it's the top side or the bottom side. Looking at my example B, I'm going to subtract my exponents. 9 minus 2 is 7, but I'm going to put my 4 to the 7th at the bottom because my bigger exponent is at the bottom. The top, I cannot leave it empty, so I'm just going to put a 1. If we were to do it the long way, there's only 2 fours on the top, and there's 9 fours at the bottom. That's why I keep 7 fours at the bottom. Looking at example C, let me just rewrite this as 5 to the third at the bottom, because remember negative exponents, and then 5 to the 7th on the top, once again, negative exponents. And I'm just going to subtract this. All right, because it's the same base, I'm going to copy the base. I'm going to subtract my exponents. 7 minus 3 is 4. Because my bigger exponent is on top, I don't need to have a fraction. So it's 5 to the 4th. Now looking at this, we're going to combine all the rules that we know. First thing on top, I'm going to get rid of parentheses. So remember, gotta multiply those exponents. So I have 4 to the 6 over 4 to the 5. I know when they're the same base, I'm dealing with division. I subtract the exponents. So I'm going to have 4 to the 1. In fact, let me even write the 1. You don't have to write. When it's exponent of 1, you don't have to write it. But it's just 4 to the 1. I don't need a fraction because my bigger exponent was on top. Now looking at my example B, this is the first thing we learned. Whenever we have the same base, I'm just going to add the exponents. So I'm going to copy the base. I'm going to add the exponents. 2 plus a negative 6, that's a negative 4. Negative 4 minus 1, that's a negative 5. So far I just added my exponents. Now, because it's a negative, I have to convert it into a fraction. X to the 5 to the bottom. I cannot leave the top empty, so 1 over x to the 5th. Now, looking at my example C, everything inside parentheses has to have an exponent. Multiply the 3 to the exponents on the inside. So I have 2 to the third, x to the third. Looking at my second parentheses, everything must have an exponent. Multiply the 2 to the exponents on the inside. So 2 to the second, x to the second. Now, I'm going to combine my bases. My base is 2. I'm going to add the exponents. So I get 2 to the 5th. When the base is x, I'm going to add the exponents. And I get x to the 5th. Looking at my example D, first, everything inside must have an exponent. Multiply the negative 4 to the exponents on the inside. So I have 2 to the negative 4, x to the negative 12, over 5 to the negative 4. Remember, we talked about negative exponents. Move it to the other side. So I'm going to have 2 to the 4th at the bottom, x to the 12th at the bottom, and 5 to the 4th on the top. Right, negative exponents make them into positive on the other side. There's nothing I can combine because there's no bases that repeat in any of my sides. So that's pretty much it. Your instructions sometimes will even remind you, we might say simplify, and then there might be something like your answer should contain only positive exponents. So that's just a little reminder. All right, so this is section 5.2.